Hello, everyone. Some students emailed me to make a tutorial and answer these questions. The purpose of using each method, that is the big question that we want to answer by using a method. How to use SAS for clustering and principal component analysis and interpretation of results. I will use SAS 8.3 as it's installed on SFU's server now. I will access it through VDI from my MacBook. For this tutorial, I will use the file serials.xls. I've uploaded a zip file to Canvas that has the file along with many other data files that we will use in this course. The MBA 3rd edition datasets XLSX2.zip. Please open SAS Enterprise Guide 8.3. It's this one. That's the one that I'm using. Create a project and import the data file, serials. You will specify the name of the sheet that you want to use. Use the sheet named data from DASL. I've already imported the file. You know how to import the file. This file has 77 rows. That is 77 breakfast cereals and 30 numeric columns, which are the attributes of these cereals. A sheet name description explains the names of these attributes. We want to use clustering to see which cereals are similar with respect to these attributes. Secondly, we will characterize these clusters. After importing the data file, please choose the task Cluster Analysis. This task. I've already run it. I can show you the options that I chose. You can choose all the numeric variables as analysis variables. Choose k-means clustering. And start with, let's say, 5 clusters. You can change the number of clusters later if you are not satisfied with your clustering results. Let's interpret the output. The first table, please do not forget to write your results to a file on SAS server. The first table has the values of all the attributes that were used to determine each cluster's centroid initially. The second table shows the number of cereals in each cluster number, and the frequency, that is the number of cereals in each cluster. Root mean squared standard deviation, the maximum distance of observation to the cluster centroid, that is how compact a cluster is or how much homogeneity exists in each cluster. Nearest cluster to each cluster indicates which clusters are similar, and the last column tells how similar these are. Higher is the distance between them, less similar these are, and vice versa. Next table shows the stats of variables. I checked manually by using Excel that the standard deviation for each column or attribute given by SAS is correct. You may ignore the remaining 3 columns for now. Cluster means this table is the most important to characterize the clusters. For example, cluster 3 has the highest mean consumer rating, 73.8. Cluster 3 has the lowest mean calories, 63. Highest mean fiber content, 11, as compared to all the other clusters. You may associate these attributes with the rating of cereals in this cluster, but we need to confirm these correlations. The last table shows the standard deviation of each attribute for each cluster. You may generate a scatter plot of calories versus ratings for each cluster to see their correlation or relationship. For example, for cluster 3, especially, seems like there is a positive correlation between these variables. Low calories and high rating. Sorry, I would repeat, there is a strong negative correlation between these two variables, low calories and high ratings. We can easily capture the correlation between various attributes for each cluster by doing principal component analysis. We will use the output of cluster analysis saved on SAS for this purpose. To do PCA, you can open the task principal components. I've already done it for you, but I can show you the options that I chose. I chose all the numeric columns as analysis variables. Analyzed by correlations, principal components to be computed. There are 13 numeric variables and I kept it to 13. And the rest, I'm generating a scree plot and a scatter plot of the principal component scores. It's up to you if you want to generate or you want to leave it like that. So I did it, so I would check this box. Then we will create output files. So please check these two boxes and also standardize principal component scores. And then click run. Here is my output. The first table shows the mean and standard deviation of each variable. We have already seen this information in cluster analysis results. The second table shows the correlation matrix of all the attributes. As you can see, there is a relatively strong negative correlation between calories and rating, minus 0.6938. Similarly, a strong positive correlation exists between fiber and ratings. Fiber and ratings 0.6034. The next table shows how much variance has been captured by each principal component. These are principal components. This is the variance captured by them, eigenvalue. The first PC has captured 28%, 0.2795. This is the proportion of variance captured in this principal component, number 1. So 28% has been captured by PC1. 24% has been captured by PC2. You have a table of eigenvectors, but you can ignore this table for now. Following that, you have a scree plot. As you can see, the maximum variance has been captured by PC1 and second largest by PC2, and so on. You may decide how many PCs you want to keep to explain your data. I will choose only 2 as the proportion of variance explained by the subsequent PCs starts declining drastically after PC2. As you can see, the slope, and also here. Let's use this task scatter plot to plot the principal component scores of PC1 and PC2. PC1 and PC2 and group by cluster and produce same axis scaling for all graphs. For all the scatter plots, please do not forget to check this box. And we are using principal component scores file that we generated by PC analysis as an input file for this task. As you can see, the observations within each cluster are grouped together with respect to all the attributes. Cluster 1, cluster 1, 2, cluster 3, 4, 5. This is the end of this video. Please email me if you have any questions.